Okay, so we're back to our Management Science Linear Programming Computer Solutions lecture. Right, so we're taking advantage of the computer applications for our linear programming modeling and graphical solutions. Before, we did all this manually, okay, using the mathematical formulas and even using Excel. We still did it, somehow manually, because we use the solver functions only under the data tools, and we also use the formula available in Excel using the mmult function. And for the graphical solution, we created our graphs using the charts, okay, Excel charts. So because of that, okay, everything was manual. We have to do it in a longer process, but actually there are applicable or available softwares now in the market, for quantitative method for linear programming, okay? And there is actually one that we can incorporate with Excel, so that we don't have at least the solver. That's easy, right? It's good that there is solver function under the data tools, but the graph, without the separate or additional software, we have to create the graph using the chart in Excel, and it takes a long time to create a graph. But if we use the separate application, which is Excel quantitative method, it is actually possible to create, okay, and formulate our linear programming model and graphically solve it, run the graph, in just one click. It is actually possible to do that in Excel, as long as we have this additional add-ins called Excel quantitative method. So the Excel quantitative method is almost the same as the quantitative method for Windows works. Okay, so let's see what is that. So if you still don't have it, of course we have to download it. Okay, so I have already searched it. So let me go back. So if you type Excel QM, I have already typed here QM for Windows for later. So we have here at the very top, search already, one that we can download. So we choose here download Excel for PCs. So this is only available for PCs if you're using Macs. So this is for Macs. So you just click download. Okay. I already have this one, so I'm not gonna repeat it. But once you click it, so you'll find your installer, of course, in your programs, Windows. Okay. If you click that and start downloading it, once you install it, you will see automatically the shortcut of your Excel QM in your desktop. So you don't have to make the shortcut. It is automatically included or put in your desktop. So let's see. So it is where, when I first downloaded it or installed it, it is where I find it, okay, in your desktop. So there's already a shortcut. Now, in order for us to use this, we have first to open a blank Excel sheet, right? So let's open a blank Excel. Okay, and once we have that, we can already click on this. If it's your first time, or if you only have one spreadsheet application, so you can just, double click this, especially if this is your first time. But if you have other spreadsheet application like I do, I also have WPS spreadsheet, and it's not my first time. So what we do is to right click this one, okay, and open this with Excel. So I choose Microsoft Excel, so that, okay, I will get the solver, the Excel for QM, Excel QM, I'm sorry, in my spreadsheet or in my Excel. So we have to choose enable macros. And once we're done with that, so it's now initiating. After the initiation, then, okay, you see here there's an additional tool for Excel QM. So earlier, I don't have it, okay? And looks like every time you need Excel QM, you have to open the Excel QM and incorporate it with your Excel. So every time you're gonna do it. So if you click on that, we'll be able to see here the different functions. Okay, we have here by chapter. So these are the different quantitative methods that are included in Excel QM. So what we need this time is the linear programming. So we choose that. And from here, we can just actually input the data that we need to solve using our Excel QM. Okay, so we have the blank sheet here, nothing. So if you want to solve, for example, let's go back to Beaver Company. Okay, and these are our data, right? Requirements and everything. Let's say we don't have it yet. We can just actually produce also the linear programming model using Excel QM. So with this, okay, we can just input here, let's say our title report. Let's say we want the report for Beaver Creek Pottery Company. Okay, and you see here we have two constraints. So the first one is about constraints. So we have two constraints, one for labor and one for clay. Okay, so this is two. If you have three, you just adjust this one. And then name for constraint. So let's just leave it as it is, constraint. And then the number of our variables. So we have two variables. We're looking for x1 and x2, or the number of bowls and mugs. So two variables. So this is good too. And the name for our variables. So we'll use x1 and x2, so let's leave it as x. And our objective is to maximize. We can leave it as this one. Okay, our objective is to maximize, and then just hit OK. And you see, after we hit OK, Excel QM actually provide us with an automatic table that we can use and fill up for running the solver. Okay, so this is the one for running Excel solver. Also, you see here graph. Okay, so later if we just click on this, the graph will automatically be provided to us. Okay, unlike if we don't have this Excel QM, and we only have the solver here under data tools, we have to create the graph, using the Excel charts, and that will take us a lot of time. Okay, so now we can fill this table that Excel QM provided for us. So what we want to maximize is x1 and x2 with coefficients of 40 and 50. Right, so we write here 40 and 50. Okay, and for our constraint 1, which is our labor, let's see if we can edit it. Labor constraint, and we will have clay constraint. Okay, so for labor constraint, we have 1 of x1 and 2 of x2. So 1 and 2. Now, it is less than or equal to 40. So it says here in the instruction that if it is less than or equal to, we just use, the less than sign. So we have less than or equal to 40. So this is good. So our right hand side is 40. And it's actually, our slack is automatically calculated for us. And then the clay constraint, we have 4x1 and 3x2. So 4 and 3. Okay? And our inequality function is less than or equal to 120. So this is good. We just write 120 here in the RHS. Right? And we have our slack or surplus already calculated for us. Now for the variables, okay, because we want to find this, what will be the value for x1 and x2, and what will be our maximized or optimal solution. So this time, we are now ready to run the Excel solver, and there it is. Okay, we automatically get the answer of 24 and 8 for our variables, and also our left hand side is automatically calculated for each of our profit and 2 constraints, right? And we have here also our objective automatically calculated to 1,360. So the good thing here is we don't have to set up the table as we did without the Excel QM. Okay, and if we want the graph, we can just hit graph here, and there you are. We already have the graph. So if you remember, okay, this is how our graph for Beaver Creek Pottery looks like, right? And also the good thing here is that our points, okay, are already defined in here. The same with our profit. For example, if our x1 is, so of course 0, 0, 0. Let's say if our x1 is at 0 and x2 is at 20. So 0 and 20. So this is this point, okay? Our profit will be 1,000. And if our x1 is 30, okay, and our x2 is 0, our profit will be 1,200. Our next corner point is this one. If our x1 is 24 and our x2 is 8, then we get a profit of 1,360. We can also see here that the goal, our main objective, which is the maximized profit, is already highlighted or is already chosen for us. Okay, so it's easy to have this here. So this is it. This is how easy things are when we use Excel QM for linear programming. All right, so let's just leave it here. So that's it. So why don't we also try to calculate the one for Flair Furniture Company. Okay, so let's create another one using Excel QM. So we should be able to get the same result here. So let's go back to our Excel. We can just go to Excel QM by chapter, okay, and we'll get another window where we can enter our new set of problem or data. So let's title it with Flair Furniture Company. Flair Furniture Company. And our Flair Furniture Company has 4 constraints. So let's not include the non-negativity constraint. So we have 4 constraints. So let's adjust it to 4. Let's leave the name there constraint. The number of variables that we have is 2. Okay, and 2. So actually, I think it's better to leave it as X here, because Excel just adds 1 and 2 to the name of the variable. Okay, so we cannot change it to T and C, things like that. Okay, so again, our goal here or our objective here is to maximize our profit. So we choose here maximize and then click OK. And we have another sheet for Flair Company. We have now a table. Okay, we can just fill it up. So again, what we want to maximize is we have the coefficient of 7 for T, which will be our x1, because we have here x1 and x2. So it will be 7 and 5. So we put here 7 and 5. Okay, and then our constraint for first constraint is our carpentry hours. So we can just rename it carpentry, so it's clear for us. So let's say carpentry hours, and that is 3 and 4, and this is less than or equal to 2,400, so this sign is good. Let's just write 24 here. Okay, and then for our constraint 2, which is painting hours, so we have 2 and 1 as our coefficients, and that is less than or equal to 1,000. For our constraint 3, which is the maximum number of tables, so let's just here maximum tables, so that is 100. So our left hand side will be 1 for table. So x1 is our table. We just have to remember x1 is our table. So let's just put 1 here and then 0 here. And then we have here 100. For the sign, we have to change it to greater than or equal to. So we have to write here greater. Okay. That's it. And for our constraint 4, that is for the chairs. So, this one is, I should have written here minimum tables, okay? Because our inequality says it's greater than, less than 2, greater than or equal to 100. So that is talking about the minimum, okay? So let me just correct it. This should be minimum tables. And then for the chairs, we have maximum of 450, okay? Because it says less than or equal to 450. What we need to find out, so meaning our constraint is a maximum, okay? So maximum chairs, right? So we have, this is chairs, so we put 0 here for table and 1 for chair, and our maximum will be 450, so our sign is good. We just write 450 on our right hand side. Okay, and this is it. We have already done it. So let's try to run our Excel solver. Okay, you see here we have 320 and 360. So let me just increase the font here so you can see clearly. So this is what we input here. And then the slack and surplus, the left hand side, are automatically calculated for us. And when we run the Excel solver, we were given 320 and 360 respectively. And our total maximized profit is 4,040, okay, which is the same with how we calculated this manually or using just the Excel solver alone under tools. Okay, so this is it. And then we can just run graph without any effort. Okay, so this is how our graph looks like if we compare it with this. So it's the same. Okay, so this, oops, I lost it. Let's go to the, let's just rerun the graph. Okay, this is it. So these are our points, you know, for our feasible region. So if x1 is 500 and x2 is 0, we will get 3,500 of profit. And if we have 100 for x1 and 0 for y, we will get 700 of profit. If we have 320 of x1 and 360 of x2, or a chair, table and chairs, we'll get 4,040, etc., etc. So this is the other point, okay? For 3,650 of profit, and this is the other point for 2,950 of profit. So our table here already shows us what is the best option, what is the optimal solution. That is when our x1 or our table is at 320 and our x2 or our chair is at 360. So this is this point, and that will give us a maximized profit of 4,040. Okay, so and then we can just copy that, and that's it. We have our graph. So lastly, let's just calculate the last problem that we have, which is a minimization problem. That is for holiday meal turkey ranch. Let's see how we're going to do it here. Okay, so of course the same. Click on by chapter linear programming, and this time let's name this holiday meal turkey ranch. Holiday meal turkey ranch. Okay, so for this we have 4 constraints. Okay, so let's increase it to 4, and then we have 2 variables. Okay, that's it, and let's also leave it as x1 or x. Now our objective is not to maximize but to minimize. Okay, so this is a minimization problem, minimize cost. So we're going to choose minimize and click OK. We'll have another sheet for this one, for this problem. So let's just also increase this. Okay, so let's complete the table created for us. So what we need to minimize are for A or x1, so that will be 0.10 and 0.15. Okay, and then for our constraint 1, which is protein, our coefficients are 5 and 10. 5, 10, and then this is a maximum or greater than or equal to 45. So minimum. So greater than, equal to 45. Okay? And then, so this is minimum. Alright? The greater than or equal to. Meaning we should, the requirement is a minimum of 45. So for the second constraint, which is vitamin, so our coefficients are 4 and 3. So we write 4 and 3. Okay, this is also greater than or equal to, that is 24. So the sign is good, we just write 24 here. And then our third constraint is 0.5 of A. Okay, for iron. That is iron. Oops, I should have written, anyway, let's see, because we just actually have 3 constraints here, right? And the other one is non-negativity constraint. But let's see if how it will change or how it will solve if we just leave the constraint 4 as our non-negativity constraint. But we don't have any RHS there. We have 0. So iron is 1.5 of A. Okay, 0 of x2. And our right hand side is 1.5. So let's see if we actually, our non-negativity constraint here, if how it will work. Let's say x1 and x2, or non-negativity constraint, maybe. I don't know how it will work, but let's see. If we put here A and B are greater than or equal to 0, so maybe we should put 1 in here, and then this is 0. So let's see if we run the Excel solver. Alright, we're still given the correct answer here, 4.2 and 2.4. And we have 0.78 as our optimal solution, which is our minimized cost. Okay, now if we run the graph, let's see. Okay, there we have it. It's still the same. We're given the same graph. Okay, so looks like with this, it's okay if we include this non-negativity constraint, since this is also constraint. It's just, it's just saying that we should not have any negative. So but even if we forget this, even if we don't include this, so we'll still be given the right solution and the right graph. Okay, so let's just remove this 2 here. Let's try to rerun the graph. What is this? Oh, okay, let's just leave it for now. We run the graph, okay, and we see here that our optimal solution is already highlighted. Okay, we have these points for our constraints, and this is it. So that's it for solving linear programming problems using the Excel QM. Okay, so this is also in Excel, but a lot better than doing this without the Excel QM. Okay, because we can just hit on run the graph and everything is in there. Okay, so later we'll discuss the QM for Windows. Thank you.